Hi everyone, today I'm going to explain why the oxidation number for certain groups are certain numbers. So what I'm going to talk about is only the main group elements. We're not going to talk about transitional metals. They are really complicated. So if you look at the screen, this is a periodic table which you will have in the test. And we have main group elements on the left and on the right. And we can actually label them as group 1, 2, 3, 4, 5, 6, 7, 8 with Roman numerals. So Roman numeral number 1 is an I, number 2 is this, and number 3 is 1, 2, 3. Number 4 is 1 and 2. Looks like a TV, but this is group 5. This is group 6. This is group 7. This is group 8. And if you notice, these are only main group elements, only the tall columns on the left, on the right, not in the middle. In the middle, the columns are really short. So I said in the class, I told you that in the periodic table, each group has certain group oxidation number. And in group 1, everyone has positive 1 charge. And group 2, everyone has positive 2 charge. Group 3 is mainly positive 3. Group 4 is changing, okay? And group 5 is usually negative 3. Sometimes could be positive 5 too, but that's special. We don't think about them yet. And on the other one is negative 2 and negative 1. This is 0. So I told you in the class you just have to memorize them, and I didn't really explain why because we actually talked about them before in our previous classes, but in case you forgot, I'll just explain it again. So I would like to take one element from group 1, sodium, as an example. Okay, so I'm going to circle sodium. So which one sodium is Na right here? Okay, this is sodium. Now if you take a look at the periodic table, you notice that it has 2 numbers in the box for sodium. One is 11 on the top. The other one is 22.99 something at the bottom, and that's the atomic mass. And here we actually have here, as you might have noticed, you have atomic number on the top, which is the proton number. Okay, so and so now we know that in sodium, in Na, we have 11 protons because that's the proton number, right? As illustrated here, okay, atomic number is on the top. So that's 11 proton. And because it's an atom, so it's neutral, it has to have 11 electrons, okay? 11 electrons, okay? Electrons. All right, so now you have 11 proton, which is positive, P positive, and that's electron negative. Okay, so together they add up to be 0 charge in total. That's 0 charge, right? Because why? 11 positive, 11 negative, it's 0 charge. And now what's going to happen for sodium is in any chemical reaction, it's going to react and lose 1 electron. Why? Why losing 1? Why not gaining something, right? Why losing just 1? Why not 2, 3, 4, right? This is what I'm going to explain. So for sodium, because it's 11 protons, so I'm going to do 1, 11 proton and positive. That's in the middle, okay? And so that's the nucleus. Now I'm going to put down the electrons on the circle, 1 and a 2. That's the 2 electrons, okay? And you have a total of 11, right? 2 are gone. Now you have 9 left. And because the first layer has only 2 seats for electrons. Remember I talked about movie theater example? I said the first layer you could have only 1 or 2, less than 2, no more than 2. And because the second layer, the first layer is full now, the electrons goes to the second layer. And don't forget that I told you when you do electrons, you do up, down, left, right. It's up to you. I don't care about the sequence that you do, but just make sure that you do for 4 single dots first before you put down the dots to pair them up. And so because 4 are sitting down and the 5th one, you have no choice but to pair up. So I pair them up. 1, 2, 3, 4, 5, 6, and the 7, and 8. So see, now you have 2 and 8, 10 electrons are done. And you have 11 electrons in total. So you have one more left. It has nowhere to go on the second layer, so the only choice for you is now to go to the 3rd layer. So I'm gonna draw a bigger circle. Okay, so the 3rd layer, you would have only 1 electron sitting down, and make sure you understand that it actually could have more electrons sit down, but the thing is you don't have any more left. So see, the first layer is 2 electrons, 2 green dots, and the second layer is 8. The 3rd layer is only 1 because you have only 11. All the atoms have a dream of having 8 electrons in the outermost shell. That's when it's most stable. And so now if you look at the diagram here, you have only 1 electron in the outermost shell. And you have 2 choices. And choice 1 is you are going to gain 7, right? Because your dream is to have 8. And you have only 1 here, and you're going to gain 7 electrons. So you could have 8, right? And that's choice 1. And choice 2, you're going to lose 1 electron. Okay, think about it. If you lose 1 electron, what's going to happen is the whole layer just disappears. The whole layer just disappears. Okay, this one disappears. So now your second layer becomes the biggest shell, and it already has 8 electrons sitting on it. So you're happy, right? Right? And now think about it. Gaining 7 and losing 1, which one is easier? I would say losing 1 is much easier, right? Because you're dealing with only 1 electron in this case, so you're going to choose this one, not this one. You're not going to gain 7 because this is too hard. 7 electrons? Are you kidding me? Too much work, right? So you're going to lose 1 electron. And after you lose 1 electron, what's going to happen to electron here? This is no longer 11 electrons. It turns into 10 electrons in total, right? Because you lost 1, right? And so now you have 11 protons. Proton number doesn't change, and the 10 electrons add up to be how many? It add up to be together is positive. Now it's no longer 0 charge. It's positive 1 charge. And this is why sodium has positive 1 charge here. And any other atom in this group, they have only 1 electron in the outermost shell. Okay, so the electron configuration for lithium, if you forget, for lithium is 2 and 1, and for sodium is 2, 8, 1. And for potassium is 2, 8, 8, 1. Okay, for rubidium is 2, 8, 8, 18, and 1. Oh, sorry. Okay, and 1. So see, now the case is everyone is ending with 1 electron in the outermost shell, and so you should lose 1 electron for everyone. So everyone is positive 1. Same thing for group 2 is positive 2 because the outermost shell is only 2 electrons. Okay, so that's why this is 2. And same thing here. Everyone is losing 3 electrons in the outermost shell. And now if you turn to this group 7 here. Okay, why is it -1? And this is actually pretty easy. Okay, let's take chlorine as one example. Chlorine, you have, well, why is it not changing? Okay, so chlorine is 17 electrons. Okay, it's 17 electrons. So the electron configuration is gonna be, okay, so 17 protons in the middle, and you would have in the second layer you would have 8 electrons because that's the second layer. So 1, 2, keep in mind a single electron every time, 3, 4, 5, and 6, and 7, and 8. I know the circle is ugly, I'm sorry. So you're going to do another layer, which is an ugly circle. Okay, ugly, sorry. Alright, so you would have this, and 17 in total, 10 already set down. You would have another 7. 1, 2, 3, and the 4, and the 5, and the 6, and the 7. Okay? Now, your dream is to have 8 electrons in total in the outermost shell, and now you already have 7. And what is your choice? You can have choices of choice 1, you're gonna add 1, okay, add 1 electron, right? So you're gonna add 1 here. If you add 1 here, 8, happy, everyone has 8. The outermost shell has 8. And choice 2, you're gonna lose 7, okay? Lose 7 electrons, okay? And if you lost 7 electrons, the inner shell becomes outer shell, and now you're happy. But which one do you think is easier? Of course, is choice 1. You have to deal with only 1 electron instead of 7. So that's why. So you're gonna gain 1. After you gain 1, so this one is no longer 17, it's 18. Yay, electrons in total. But the proton number doesn't change. Still, it's 17. So 17 protons. And 18 electrons. And how much charge in total? It's 1 electron. 1 negative charge. So that's why chlorine, this group, is -1 charge here. And notice that not only chlorine has 7 electrons in the outermost shell, the rest of it, everyone has 7. So everyone has -1, that's why. And group 18, if you notice, that's 0 for everyone, okay, 0 for everyone, because why? It's already having 8 electrons in the outermost shell. It's happy, it's not going to react with anyone, that's why. And group 14, people ask me, how about group 14? Group 14 is changing, actually. It has changing oxidation number. Why? Because it has 4, and you could lose 4, lose 3, lose 2, lose 1, gain 2, gain 3, gain 4. You could have 0 or -half, +half, -3.5, and the +3.5 charge. You could have many charges. So we don't actually think about a fixed oxidation number for group 14. Or group 4, main group elements. But we do have to know that everyone in group 1 is going to be +1 and +2 and +3, and then it's -1, 2, 3, 3, 2, 1, and 0 here. That's the thing you definitely have to keep in mind. So that is why if you have any other questions, please let me know. Thank you.